In this digital world we live in, the semiconductor industry is vital for the advancement of our technology. In this video, we are going to discuss the different types of chips there are, how they're made, and the challenges that the industry faces today. So let's dive right in. What kind of chips do electronic devices use? There are two different types, analog and digital. Digital chips are built to store and process information represented by binary digits, and only deal with discrete variables. They use digital circuits that operate on two states, either on or off, representing the binary digits 1 and 0. They are commonly used in computers, digital signal processing, and telecommunications. These chips are more expensive to buy and have quicker product cycles. Analog chips, on the other hand, are designed to process continuous signals such as sound, light, temperature, and pressure. They convert these real-world variables into signals that can be understood by the digital chips. To do this, they use analog circuits that operate on continuous voltages and currents, and the output signal is a representation of the input signal. Due to this, they are commonly used in audio and video processing, power management, and sensors. They are less expensive for the consumer and have longer product cycles. The main differences between analog and digital chips are the type of signals they process and the type of circuits they use. Analog chips process continuous signals which produce a sine wave. Digital chips, however, process discrete signals that are values of off or on. Due to this, the signals display a square wave. When it comes to circuits, analog circuits are typically more complex and require more components than digital circuits, while digital circuits are simpler, more reliable, and easier to manufacture than analog circuits. Now that we know the different chip types, how exactly are they made? A basic overview of the manufacturing process begins with the initial construction of a silicone pillar known as an ingot. This is created when sand is melted into a liquid and then solidifies through crystallization. This ingot is then sliced into thin discs known as wafers. Once sliced, the wafers are polished for a smooth, clean surface. A layer of photoresist is then applied to the wafer's surface. The photoresist is a light-sensitive material that will be used to create the chip's pattern. The wafer is then introduced to ultraviolet light through a photomask, which contains the pattern of the chip. The photoresist that is exposed to light will be chemically altered, while the areas that are not exposed will remain unchanged. It is then baked at temperatures higher than 1200 degrees Fahrenheit or 1100 degrees Celsius to make the modifications permanent. Finally, the wafer is etched to remove undesirable elements and create a three-dimensional circuit. Due to the rapid changing of information processing technologies, it has been projected that the number of transistors in an integrated circuit will double approximately every 2 years. This is what is known as Moore's Law, which was introduced in 1965. Moore's Law is significant as it has sparked industry-wide innovation. Chips included 3 transistors in 1970. While today chips contain around 5 billion transistors. Chips get quicker, more powerful, and more energy efficient as the number of transistors increases. This only applies to digital processors, however, not analog. Although the industry has managed to follow it up to this point, it is debated whether or not this observation is still valid due to the deceleration of the increase in chip densities. Despite it no longer doubling every 2 years, it is still presenting rapid improvements, just at a slower rate. With that being said, we need to look into the industry itself. The industry has experienced quite the restructuring since 1980, moving from vertically integrated chips, where one company has direct ownership of all of the production process, to fabless models. The term fabless means that the production of chips is outsourced to a specialist manufacturer known as a foundry. A fab's job is to plan and design the semiconductor chips, while foundries focus on the manufacturer side of the process. Specialized players allow for more rapid innovation. Collaboration between players, on the other hand, is critical. Geopolitical tensions have arisen due to the strategic importance of the semiconductor industry. The conflict is mostly between the United States and China, as the United States controls the top end of the supply chain due to its tight ties to Japan, Europe, and South Korea. The US and EU Chips Act are promoting local production to reduce reliance on other countries, but there are concerns that China could invade Taiwan and seize its chip manufacturing industry. If this were to happen, it would be a momentary complication for the industry, but the West would be in a stronger strategic position in the long run. The semiconductor industry continues to grow, with equipment manufacturers providing essential equipment for fabs and foundries, manufacturing the chips that clients need. Understanding the semiconductor industry's complexities helps us better appreciate its importance and significance in our daily lives. We hope that you found this helpful. If you have any additional questions, don't wait. Get connected with us by visiting our website at www.apexwaves.com, where our dedicated team will provide the support you need. Thanks for watching.